Hey, hope you're doing good. Back to solving more problems on arrays, and today's question is merge intervals. It's quite a popular question and has an interesting solution as well. You could pause the video and quickly go through the question. We have a list of intervals where each interval has a start, end index, and we need to merge all the overlapping intervals and return the array of the resulting non-overlapping intervals. So for the first example, we have 1, 3, 2, 6, 8, 10, and 15 and 18. From this list, we see that 1, 3, 2, 6 are overlapping, so we have 1, 6 as the output. We then have 8, 10, and 15, 18. Let's visualize this example and see how we can try solving it. Here's a question with these intervals, and we have a number line drawn below to visualize these inputs. So we have 4 intervals, and let's start plotting these on the line. So we have the first one being 1 to 3, and let's use different colors so that it helps plot these on the graph. The next interval is 2 to 6, so we have 2 to 6, and the next interval is 8 to 10, and the last one is 15 to 18. So if you have a look at these intervals from this graph, it's quite evident that the first two overlap and the second two are unique by themselves. And from this, we can determine that the answer is going to be 1 through 6, 8 to 10, and 15 to 18. It's quite evident when you have a look at this graph to try to group them or break them down into overlapping and non-overlapping intervals. But the main problem here is to identify how we can solve this programmatically so that there's a process to determine which intervals are overlapping. So the first thing we observe that it's really helpful to start with an interval that has a smaller start index. So in this example, we started with 1, 3, and then came across 2, 6. This helped us identify that 2, 6 falls within the end of 1, 3, and we could identify them as overlapping. But let's say we started with 2, 6, and then came across 1, 3. It's harder to identify because we're first starting with 2 and going through 6. Then we have an interval that's coming earlier but still ends at 3. It might still be possible, but it's quite hard to do it when there's no order to these intervals, and once we go through a list, it's possible that an overlapping interval can come in the future. So from this graph and from what we discussed, it's quite evident that sorting these intervals based on the start index is really helpful. So in this case, the list is already sorted where we have the starting indices, which is 1, 2, 8, and 15. They're already in that order, which is helping us identify or group the overlapping intervals. So we have the list sorted based on our start indices, which are ordered as 1, 2, 8, and 15, and we start iterating in this order. So we first start with the interval 1, 3, and let's call our end index as current underscore end, which is equal to 3. So we have 1, 3, and our current end is equal to 3. We then look at 2, 6. So in 2, 6, we see that the start interval 2 is actually less than our current end, which is 3. It actually needs to be less than or equal to. So even if the new interval started from 3, it would still be considered overlapping. So we group that together as 1 being the start index and the end being the max of current end and the end from the new interval. So we have 3, 6, which means we treat it as 1, 6. So 1, 6 is our new overlapping interval. We then have a look at the next one, which is 8, 10. 8, 10, 8 is the start index and our current end is at 6. So 8 is actually greater than 6, so it would be a new interval. So we add it as a new interval called 8, 10, and our current end now points to 10. Then we come across the last interval, which is 15, 18. 15 is greater than our current end, which is 10. So that's a new interval again, and we have 15 to 18 being the third one. This would be our final result with these three intervals. That solves the problem. And visualizing or plotting these intervals on a graph greatly helped understand how we can arrive at the solution. All right, let's write some pseudocode to see how this can be implemented. So we have a function called merge, which accepts intervals as the input. So we first need to sort intervals based on start. And then we can iterate over the list. So the first condition we need to check is if let's actually use another variable called result to store our merged intervals. So the first condition can be to check if res is empty or the last interval in res is actually less than the new interval, which would be interval of 0. In this case, it means that the interval is not overlapping and can be appended to the result. In the else case, it means that it's overlapping, which means we need to update our current end. And the current end can just be updated as the last element in result will just be the max of the last element in result or the new end interval that we're seeing. So as we go through the entire list, we have our new set of merged intervals in the result, and we can just return result. Let's have a look at the space and time complexity for this. So in terms of time, we're first sorting the entire list based on the start element and then iterating over it once. So the sort itself would be big O of n log n, and the iteration would be big O of n. So finally, our time complexity is big O of n log n. And with regards to space, we are using a new list for storing the merged intervals, and in the worst case, each of them would be a separate interval. So the space complexity would be big O of n. All right, let's go ahead and code the solution. We have a function called merge with intervals as the input. So as a first step, we can check if intervals is empty or none, and then we can just return. We now need to sort intervals based on the start index. So in Python, we could use the sort function. And since we want to sort it based on the first element, we need to pass in a function as a parameter here, and the function must return what it needs to be sorted by, which is the first index. So since it's a simple function, we could just pass in key is equal to lambda x being the input, and we want to sort it by the first index, so it'll be x of 0. So lambda can be used to write simple functions or one-line functions in place. And then we want a result array to store the merged intervals. And we can also have n, which will be the length of the intervals, and we might use it in multiple places. We iterate over all the intervals. The first thing we want to check is if result is empty or if the last element or the current end of result is less than the new interval. So we do if not result or result of, in Python we could do result of -1, which refers to the last element in the array. And then we want the end index, which is at index 1. And we want to check if that is less than the start index of the next interval. If in this case, it means that they're not overlapping. So we just append the interval to the result. So for a given example where we had 1, 3, and 2, 6, in the first case, result is not there, so 1, 3 would just be appended. In the else case, it means that it's overlapping. So when we, for example, came across 2, 6, so 1, 3, so this result of -1, 1 would refer to 3, and interval of 0 would be 2. So 3 is not less than 2, so it would come to the else, and we need to expand our current interval. So we can just update our end index, or current end, which is a result of -1, -1, 1, to the max of our current end. And the end index for a new interval. After we go through the entire list, we have our merged intervals in result, so we just return our yes. I think this looks about right. Let's run the code to see if it works for the given example. Looks like it does. Let's go ahead and submit the code to see if it works for all possible inputs. Yes, it does. So from this example, we saw that visualizing or plotting the given problem on a number line or a graph greatly helps understand and simplify the problem. And this was merge intervals, but there's a lot of similar questions for this, patterns like meeting rooms and other questions where we want to understand which intervals are merging, and sorting based on the start index and iterating in that order greatly helps solve such questions. Hope this helped. Thank you.